Hi, this lesson is on analyzing function graphs. So we're going to talk about some ways we can describe and analyze graphs. If you were to look at this graph that you see here, what would you say? You've kind of got almost like a roller coaster track graph, and you'll notice, it's going up, and then it starts to decrease down to here, and then it goes up to this spot here. And so we have some different peaks and valleys, and we have some increasing intervals, some decreasing intervals. So there's just some ways that we can summarize graphs like this, and we're going to talk about how you would do that. Okay. So one of the ways that we can talk about first is just where things peak and where they hit the valley. Those are called maximums and minimums. Now we have absolute maximums and absolute minimums. An absolute maximum is the highest point on the graph. So you see that here, right? Absolute maximum in the graph that you see, where's the highest point that you're going to see? So this right here in this situation would be an absolute max. The lowest point on the graph is your absolute minimum, okay? So this is my absolute minimum, okay? We also have something that is referred to relative maximums and minimums. And the definition for that is this. This is the highest or lowest point compared to the points that are close to it or right around them. So I'm going to do this in red. So we do have here a couple of relative maximums. This would be a relative maximum, because in relation to the points next, so like right here, right? In relation to the points like in this area and this area, it is right next to it, it is the highest point. So we call that a relative max. And we actually have another one right here. And sort of the same situation. The points next to it, it's higher than the points right around it. It's not the highest, right? Because our absolute max is higher than those relative ones. But in relation to the points right next to it, that's why we call it a relative maximum. And we also have a relative minimum. And you can see here we have a couple of these, one here, and then also one right here. So these, in relation to the points close to it, like this point, these points here, it's the lowest point. And same thing with this one over here, right? So that's how we would describe maximum and minimums. We can have absolute ones and relative minimums. Okay, so let's zoom in on this right here. What is our maximum, which would be our absolute maximum? In this particular point, it would be, let's do this in maybe purple here. That's this point right here. That's my absolute maximum, it appears. So when we say what is the maximum value, we're really saying how high does that get? So the absolute maximum would be 5, and we would say that would occur at x equals here. That's 4. Okay. All right. So that's my absolute max. My absolute minimum, where's the lowest point on the graph, would be this one here. And that goes all the way down to -6. And that is at x equals 2, right here. Okay. And then, okay, relatives. Let's do relative. I don't know, let's try orange. Relative maximum, or there you could have multiple ones here. So we have a relative minimum, it looks like right here, at that point there. I only see that one. So that's -2, it looks like. At x equals -3, right there. All right, and then a relative maximum, it looks like I have a relative maximum right there. And that goes up to 2, it gets a height of 2. And that occurs when x is -1, right? Okay, so that's how you analyze maximums and minimums and the difference between a max that's an absolute one and a relative one. Okay. Okay. All right, now let's do the same thing here for this sort of weird one here. Absolute maximum, it looks like that would be right here, right? Okay, so that goes all the way up to, in this case, it looks like 8. When x is 6, right? Yeah. Okay. And let's see, my absolute minimum looks like it occurs down here. What does it get down to? It looks like -6. And that occurs when x is 9. Okay. Let's do some relatives. Okay, relative max. It looks like I have one here and one here. This isn't one because it just keeps it's still kind of going up there, so that's not one. Okay, so it looks like I have 2 relative maximums. Let's start with this one over here. That would be, it gets up to a height of 6 at x equals -5. And also a height of 3 on this one. That's our next one. I guess 3 at x equals 1. I should have written that smaller, but you see how that works. Okay, and now let's do a relative minimum. So it looks like I got 2, one here and one here. Okay, so that would be 2, I'm sorry, that would be -4 at x equals 2. Okay, and then my other one would be, goes down to -6 at x equals 9. Oh no, that was my absolute minimum. So not that one. We already did that one, right? Okay, so I only have one relative minimum. All right. Hopefully that makes some sense. All right, which of these functions has a maximum or a minimum? Okay, so now this function right here, you might recognize that that's in y equals mx plus b form. So that's a line, right? It's kind of going like this. Now it's always increasing from left to right. So that has no maximum. It goes all the way up to infinity, but since it's always increasing, it has to peak at some spot. But that one's always increasing. All right, this one here, I graphed that on Desmos. So here is that function y equals negative 1/2 to the x power plus 4. And you see, well, we can zoom in a little bit here. It's an exponential function, right? Now you'll notice this line here across at 4, but it's actually always increasing again. It gets really, really close to 4 for a height, but it actually never reaches it, but it still is increasing, even if it's only very, very small increase. As we go this way, you know, look, right? It never goes up to 4. It looks like it does, but it actually never touches. So just kind of a weird function there. That one doesn't have a max either. So then what about this one? Well, we know that's a V. So is it upside down? Or like, what does that look like? So we could graph that on Desmos. Let's do that. Let's get rid of that. The function was y equals, I think it was x plus 1. And then I think it was plus 2. Let's just double check that I typed that in right. Yeah, x plus 1 and the absolute value of x plus 1 and then plus 2. So you'll notice there it is. And it does have a minimum. It's right there. It looks like it's at, the minimum is at positive 2 and when x is 1. Okay. So which one has a maximum or a minimum? This one has a minimum. That's the only one. So you can use Desmos to kind of help you with that. Sometimes it's a little bit easier than the graphing calculator. All right. Also, axis of symmetry. So an axis of symmetry is simply another way of saying a line of symmetry. So it's just a line that divides the graph symmetrically. Both sides of the graph are mirror images. So which of these graphs have an axis of symmetry? All right, so let's look at right here, this first graph. There's a line of symmetry right down the middle, right? It's a vertical line, but this side of the graph looks like this if you were to mirror them over or flip them over. So there's one axis of symmetry. Same thing with this. This is the line of symmetry right here down the middle. And then this one does not have one. We can't find a line where that would be exactly the same. So the first two. And you can try to graph some more and just see where they are, but it's just a little bit of practice and getting used to that. Okay. End behavior. End behavior is a little interesting. So this describes what happens to the function as x approaches infinity and negative infinity. And when we say as approaches, you oftentimes will see this like arrow. That means approaching, or approaches. So down here in this first one, it says, well, for both of these, it says to describe the end behavior of each graph. Now, let's zoom in here on this one. This first graph, this is a cube root function, and it's kind of got a sideways squiggle. But basically what you're thinking of here, it says here as x approaches infinity. So here's x. As x is going this way, as we start to go that way, what's happening with this graph? Is it going up, down? We're really saying h of x is doing what? Is it going up or down? You can see that it's continuing to go to the right, but it's also going up. So we're really saying the y value, what's happening with that? It's going up. So it's approaching infinity. In other words, it's going that way. Okay? Well, how about as you think about starting from the center of this, it also says as x goes to negative infinity, so as you go this way on the graph, what's happening with y? Well, the graph is going down, it's also going to the left, but it's also going down. So y value, it's going down that way to negative infinity as well. So sort of an odd thing to think about. This is called end behavior as it's happening at the ends, positive infinity and negative infinity, as the graph approaches those two values, as x does that, right? So here, okay, so as x goes this way, what's happening to g of x? So in this case, it's going down and down and down, but it's going really close to zero. It's getting closer and closer and closer to zero, but it's not actually reaching it. So this one, g of x, is actually getting really, really close to zero. It's approaching zero, but never reaching it, actually. So as we go this way, as we approach negative infinity, as x approaches negative infinity, g of x is going way up. It's approaching positive infinity. This is called end behavior. And let's kind of talk about this now in terms of what we've just learned. So kind of 4 main elements of the graph. Okay, we've talked about domain and range before. We introduced maximum and minimum, and then axis of symmetry, and then end behavior. Okay, so what is the domain of this function? It's a square root function that's been moved or slid a little bit to the right. So the domain is, what can I plug in for x? Domain, you'll notice here on my graph, it's really x is only from here over to the right. So anything 5 or bigger is okay. So I'm going to say x has to be greater than or equal to 5. Or you might say the bracket x such that x has to be greater than or equal to 5. This is just another way to write that. The range is the y value. So that's from how far does it go up and down. And you'll notice here the graph doesn't go any lower than this. It goes there and then goes up. So this would be y is greater than or equal to 0. From 0 up, right? Okay. All right. Is there a maximum or a minimum? There is a minimum. It's right here, right? So min is 0, right? When we talk about maximum or minimum, we're going to save the y value. So the lowest that goes is 0. And then at x equals 5. Okay, is there an axis of symmetry? In this particular graph, no. Okay. Okay, as x approaches infinity, so as we go this way, what's happening with the graph? Well, it is getting bigger. So the graph is approaching infinity. Now, this one is kind of odd. As x approaches negative infinity, what's going on with this graph? Yeah, it's a little tricky, right? There's not really anything we can do with this one. As it goes this way, it's sort of undefined. All I can go is to here. So that one's a little weird. And so we're not really gonna deal with that. Okay, so I hope that makes sense. That's really all we have when we talk about different ways of analyzing graphs for our course right now. All right. See ya.